Hello class, today we're going over lesson 4.1, how to construct and interpret scatter plots. So let's start off with our definitions for today, and we have a lot of them, so you might want to pause the video to get these down here. So start with the scatter plot. A scatter plot is a graph on the coordinate plane that shows the relationship between two sets of data. So in a scatter plot, you have a bunch of different things, and that's what these are right down here. So you have things like gaps, clusters, and data. So on a scatter plot, a cluster is just a collection of points. So if we're looking at like an X and Y axis here, and we see a bunch of points together here around like that, then we would call this a cluster because it's a collection of points that are close together. So a gap on the data is an area on the graph that contains no data. So if we have the same cluster right here, and then we have another cluster over here, we would call this area in between the gap, because there is no data in that area. Next, data. So data is just information that is plotted on the graph. So each of these individual points here that make up these clusters would be considered data because it is information that is plotted on the graph. Next, we have a negative association, and that means that your y values decrease as your x values increase. So remember, our x values are the ones on the bottom line here going horizontal, and our y values are the ones going vertical. So if we have a graph that as our x values increase, or as they go in this direction, and our y values decrease like this, then this would be a negative association, because notice how our y values are going down while our x values increase. Next is a positive association, and a positive association is just the opposite. The y values increase as the x values increase. So it could look something like this here, where our values are just constantly going up for both the x and y axis. The y axis is now increasing as opposed to decreasing. Alrighty, so putting that all together in a picture for us here. Well, first we have an outlier. So an outlier is a data point that is far off from the other data points. So notice here we have a cluster because all of these points are close together here. And notice we are determining that based off the x and y axis. Our x axis is hours of sleep, and our y axis is the math test scores. So notice as the hours of sleep increases, so does the math test scores. So we would call this a positive association because the y values are increasing as the x values increase. Now we can see here also that we have a gap because there's a huge gap here, or a missing space between our cluster and a data point. And since this data point is so far out, we can call it an outlier because it is far away from the other ones. Alrighty, so our goal today. Today we are going to learn how to construct a scatter plot in order to graph paired data. Once doing this, we will utilize the scatter plot to identify and interpret the relationship between the data. Excuse me. Okay, so start with an example here. Phoebe constructs a scatter plot to show the data. What scale should you use for her x and y axis? So if we want to draw ourselves a little graph here where we can have an x and y axis, it would look something like this. Now go ahead and ask yourselves for a second, should our x-axis be the vertical line or the horizontal line? Should the x-axis be the one going up or the one going over? Think about that for a second. If you thought that the x-axis should be the one down here, you are absolutely correct. Our x-axis is on the bottom and our y-axis is going up. So here's our x-axis and here's our y-axis, and it wants us to know how we should label them here. So to me, I think our shoe size should be on the bottom here. Shoe size should be our x-axis. Shoe size. And for our y-axis, we can use height here. It's terrible, but you know what I mean. And this is in inches. This is our height. So our shoe size and then our height. Whenever we have a table like this here, your x-axis is usually the one that comes first. So this would be our x-axis and this would be our y-axis. So the x comes before the y. Now if we were to graph this here, we could, for example, go over to 8. We'll say that's imaginary right here, and then come up to 60. Again, we'll imagine it's right there. And then our first point would be right here. And then from there on, we could graph other points. We have a 764, so maybe something like right there. We have an 8, a 63, maybe in the middle, a 6 and a 60, so maybe even shorter, but still at the 60 line, a 5 and a 54, so that would be down here. And you get what I'm doing here, right? I'm just graphing the points, but that's not what we were asked to do. We're kind of getting ourselves a cluster, though. So basically, if Phoebe wanted to construct a scatter plot to show the data, she could label her x-axis the shoe size and the y-axis the height. All right, so Jermaine constructs a scatter plot to show how many people visit different spring parks in a month. Why might clusters and outliers be present? So if we're looking at the scatter plot here, we're seeing that we are decreasing, then we're increasing, decreasing, got a little bit of an outlier here, and then increasing again. So if we're keeping track of this here, we see that our x-axis is our months and our y-axis is the number of visitors. And this is for visitors at a theme park here. So why might clusters and outliers be present? Well, if we're looking at this here, it appears we have a cluster up here, a cluster down here, and also one outlier way down here, right? So kind of why did these develop? Well, let's think about what we're looking at here, right? We're looking at visitors in a theme park. So if you're going to a theme park, you're probably more likely to go to it in the summer, right? Which is why we might see these clusters around the 6 to 8 month trend, because this would be during summer. Notice how when we get towards winter here, in the 12 to 11, or excuse me, 10 to 12 range here, we are decreasing, so that might cause it to go down. So our clusters could be changed by season here. Now we just have to answer why we might have outliers. So the outliers could simply be due to the fact that we are in a kind of like a bad weather area, right? Like maybe right here the weather wasn't so great, so not as many people are going to the theme park. Only like, I don't know, 1,000 people went or something like that. So the outliers can be due to weather or basically some other unforeseen circumstance that is stopping people from coming to a theme park here. But basically, as long as you're able to identify the outlier, which again was this one right down here, and the clusters, which were circled up here, then you can clearly see that we do have clusters and outliers in this graph, and they must be related to some outside factor. Okay, keep rolling here. I think we got one more example. Okay, so make a scatter plot for the data. So we have a different number of months going on here, as well as the number of people in thousands. So let's go ahead and draw ourselves a line here. Oops, hold up a second. I don't want it to be red. So if we're keeping track of this here, we want our x-axis to be the first one, our y-axis to be the second one here. So this is our months. This is, oops, that's spelled wrong. Oh gosh, months. There we go. I promise I could spell. This is our number of people. And it's in thousands, but I'm not going to write that. And then finally, we have the museum attendance right here. So let's go ahead and start labeling this here. I want to label this by 5s, I think, for our number of people. So we'll go 5, 10, 15, 20, 25, 30, 35, 40. 40 is as high as we have to go because 39 is the largest number. Next, for our months here, let's just label them by 1. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We got 12 months here going from 1 to 12. Now let's go ahead and plot our points. So again, since these are our x-axes here, or our months are going for our x sides, we could just go ahead and make these points here. So at 5 months, we have 6,000 people in attendance here, so that would be the point 5, 6. So go over to month 5, 1, 2, 3, 4, 5, and we'll go up to 6,000 people, which would be approximately right here. Next, also at 5 months, we have 12,000 people attending. So still at month 5 here, we're going to now go up to 12,000. All right, again, at 5, we again have 5 months going past here and 9,000 people here. So we'll have a 5 and a 9. It should be somewhere in between those two. Now we're getting on to 6. So over at 6 months, we have 6,000 people in attendance. So we could put a dot down here. Again, 6 months, 12,000 people in attendance. And then, big one here, 6 months, 39,000 people in attendance. So we're right up here. So we've gotten this far so far. Next, at 7 months, we have 6,000 people in attendance. So we'll come over here to 7 months and put a line up at 6. Next would be 10 months. So that would be this one right here. And we have 21,000 people in attendance. So we would be right about here, I think. Next, we have 10 months again with 27,000 people. So we'll go to the 10 months and then over to the 27 right about here. Again, 11 months with 18,000. We'll come over to 11. We got 18,000, which is right about here. And then lastly, 12 months with 27 and 6. So we've got the 6 here and the 27 right about here. So this is what our scatter plot would look like. It's a little spaced out with a lot of clusters, right? So we can kind of think about for a second, why might there be clusters here? Why might there be clusters here? We'll go ahead and answer that in a discussion later. Well, actually, let's just think about it now. If we're looking at this, well, the clusters could be caused by like a large event, right? Like, for example, maybe here when we had this 39,000 people attend, which is way up here, this is an outlier, right? Because it's nowhere close to our other data points. This could be a special event, something that wasn't going on. Whereas here, this could have just been like a high point of activity for the museum. A lot of people were going. And same with over here. Alrighty, everybody. So we're going to go ahead and get on to discussion questions here. So make sure you guys are thinking about these and ask questions in class if you have them. Is it true that every scatter plot will have a cluster gap and an outlier? How does a scatter plot show the relationship between paired data? And consider the scatter plot. Why might clusters and outliers be present? Alrighty, so in conclusion today, we learned about constructing a scatter plot, and we were able to analyze our scatter plots based off things like outliers, positive associations, negative associations, and clusters, things like that. Alrighty, guys, don't forget to write this conclusion here. I'll see y'all tomorrow. Have a great rest of your day. Peace out, y'all.